All right, so here's a big day. Imaginary numbers. You didn't even know imaginary numbers existed. You might be like, do imaginary numbers exist? Why do they exist? They're called imaginary. So I always talk about back when you're a little kid and little kids learn to count. What do they learn to count with? What number? 1, right? 1, 2, 3, 4, 5, right? And then one day you're like, hey, guess what? There's a number before 1. It's called 0. And that's like a whole thing, right? To understand 0, 0, I had 1 toy, got taken away, now I have 0 toys, right? So if kids are like, okay, fine, 0. And then you get a little bit older and they're like, hey, guess what? We never told you, but there's actually negative numbers. Kids are like, what? I thought numbers started with 0. You told me it started with 0. And before that, you told me they started with 1. Now you're telling me there's negative numbers? Yeah, there's negative numbers. When it gets really cold outside, it might be like negative 10 degrees, right? That's negative numbers. Oh, and by the way, all those numbers are on the number line. Oh, okay, fine. So you thought that, you knew all the numbers that there are, but turns out there's another one we never told you about. It's the number I. I is equal to, wait for it, the square root of negative 1. What? I thought you couldn't take square roots of negatives. Well, it turns out that you can. We just didn't tell you about it yet. So now we're telling you that I is the square root of negative 1. So if I have the square root of negative 36, this could be like the square root of negative 1 times the square root of 36, or we're going to write this as 6i. Similarly, the square root of negative 64 will be, right, 8i. Good. What about the square root of negative 32? Well, just like simplifying square roots before, it's going to be 4i root 2. Anytime we have the square root of a negative, we get an I. Or like in number 4, we could just take out the I root 5. Okay, fine, a little bit getting used to, whatever. What about the next one? 6i minus 17i. Oh, we just combine like terms, negative 11i, just like it was a variable. Now number 6 is going to bring on a new rule, 6i squared, right? Well, if I is the square root of negative 1, what would I squared be? Well, wouldn't it be the square root of negative 1 squared, right? So the square root of negative 1 squared is, ready? Negative 1. So 6i squared can and needs to be reduced to negative 6. Okay, I'm going to put a star by number 7, and I'm going to write a little helpful hint. Take the i's out first. Take out i's first. So if I take out the i's first, that means I make the problem I root 5 times I root 20. If I multiply that together, I get I squared root 100. The square root of 100 is 10. The square root of 100 is 10, and what's I squared? Negative 1. So the answer there is negative 10. If you don't take the i's out first, you get 10, which is not the right answer. There is one like that on the test, so you need to take the i's out first. What about number 8? What does it feel like? What kind of problem? Rhymes with boil. Yep, it's a FOIL problem. First outside, inside, last. 18 minus 24i plus 6i minus 8i squared. But what's I squared again? Negative 1. Negative 1 times negative 8 is 8. 8 plus 18 is 26. So it's 26 minus 18i. Same thing with number 9, 25. Now you could probably see what's going to happen here with the inners and outers. Can you see that? What happens? Yep, they cancel out. Negative 9i squared is the same thing as, right, positive 9. So the final answer there is 34. And then number 10, we want to make sure we don't get what? Foiled again. We want to make sure we write it out 2 times. 3 times 3 there, 9. It doesn't want to do the top of whatever I do. 9 plus 6i plus 6i. That's a plus there. So it's going to be plus 4i squared. 4i squared, same thing as negative 4. 9 minus 4 is 5 plus 12i. Perfect. And just like that, we're at the bottom. Now, oh, we're not quite at the bottom. We're in the middle. Sorry. Dividing by I, you won't be shocked to know you can't have an I in the denominator. Why not? Right, because I is a square root, and you can't have a square root in the denominator. So we got to get rid of it. How do you think we get rid of it? See how smart you are? Multiply top and bottom by I. So now I'm going to get 7I over I squared, or 7I over negative 1, or negative 7. 7 divided by I, fun fact, equals negative 7. How do I get rid of the I in number 12? Right, it doesn't matter that there's a 3 there. I'm just going to multiply top and bottom by I. So I get 7I over 3I squared. But what's I squared? Negative 1, so 7I over negative 3. I bet you can guess number 13 with this expression in the denominator. Right, it's the conjugate, 7 minus I, 7 minus I. So now you get like foil, 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 foil. So the numerator becomes 14 minus 2I, that's a 2, plus 7I minus I squared. Denominator 49 minus 7I plus 7I minus I squared. Remember what I squared is negative 1. So negative I squared is positive 1. So positive 1 and 14 in the numerator there becomes 15, and then plus 5I. Denominator, what happens to these two terms right here? Cancel out, right? And we get 49 plus 1, which is 50. Question, can that be simplified? You're right, it can. I can factor a numerator, a 5 out of the numerator. 3 plus I over 50. And this has to be done, by the way, and then those cancel. So my final answer, 3 plus I over 10. 3 plus I over 10. Okay, 14. Grand finale here. I'm going to multiply top and bottom here by 2 minus I root 3. 2 minus I root 3. 2 minus I root 3. Numerator, I'm going to save, so I'm going to not distribute the 4 just yet. 2 minus I root 3. Doesn't want to write. That's 2 minus I root 3. That's a 3. Funky looking 3. And then the denominator, 4. Outers and inners cancel out. The last term is going to be minus I squared times the square root of 9. Minus I squared times the square root of 9 is just plus 3. So my final answer, I could distribute the 4, I guess. 8 minus 2, come on, 2I root 3 all over 7. Sorry for the writing. Okay, trying to wrap this up here. Powers of I. So I'm just going to go with it. So powers of I, you know that I is equal to I, right? And what's I squared equal to? Right, I squared is equal to negative 1. I cubed, I'm just going to tell you, is equal to negative I, and I to the 4th is 1. I can explain why. I cubed is I squared times I to the 1st, because 2 plus 1 is 3. And I times negative 1 is negative I. I to the 4th can be thought of as I squared times I squared, or negative 1 times negative 1, which is 1. Now, as we discussed in class, this is going to continue a pattern. Negative 1, negative I, 1. I, negative 1, negative I, 1. I, negative 1, negative I, 1. And I can go into reasons why it repeats, but my pen's not working. It's just going to be like, you have to trust me, the pattern repeats. So if I want to do I to the 6th, I can look on my chart and say, hey, it's negative 1. I to the 13th, I could look on my chart and say, hey, it's I. But what about I to the 100th? It's not on my chart. How do I figure it out? Right, it's 1. Why is it 1? It's a multiple of 4, right? So you saw the pattern. Every time we get to the bottom here, like we look at these bottom ones, they're all multiples of 4. So if I to the 100th here would equal 1, when you start over at I to the 101, you're starting over at I. And we have a little catchphrase to help us with this. It's called I1, negative in the middle. I1, negative in the middle. Takes a while to get it. It doesn't make much sense, does it? I1, negative in the middle. I1, negative in the middle. So there you have it, imaginary numbers.